thank you everybody for coming out, and thank you for Arthur, and eventually Kathleen will join us as well. So my name is Shaun Belcher. I'm the Executive Director at the Tezos Commons Foundation, and we primarily focus on curating and promoting the grassroots communities of Tezos. And so I want to step through just a few points on here. AJ was nice enough to supply me with this, this presentation. It tells a little bit about what we do and how we operate in a decentralized environment. So the Tezos Commons Foundation was born from the community, and we were voted in. Effectively, we're a group of about 70 people early on who decided that the community needed a voice and needed a way to operate in the new commonwealth that we were building online. Effectively, all of us were enthusiasts. We were scientists, engineers, people with financial backgrounds, and we were just captured by the idea that we could create this massive network of value, and together we could coordinate resources. What I find very interesting about Tezos in general is that it was very contrarian for its time, as it went against the fork-based governance. I guess you could call it the idea or the zeitgeist. So I still think it's very relevant today, and I think it's become more relevant in the governance aspect. So effectively what we did was we pulled together our actives on Riot and other areas of the community. Very early, it was late 2017, early 2018, and we established a legal entity in Utah. And so from this, we've sort of taken on a role of promoting Tezos and running global meetups around the world. So our purpose, facilitate the creation and execution of community engagement, the purpose of advancing the Tezos ecosystem, driving awareness, trying to talk to people online, let them know that this project is still alive and we're thriving today. We've received a lot more media attention, but we're continuing to grow as people start to realize that it's solving numerous needs, but most importantly, it's adapting for the future needs. So our main objectives: community events, sponsored training programs, marketing, hackathons, technical workshops, dev meetups, community outreach. But most of all, we try to get to know people that are both interested, they're building on, or have contributed to the project. Try to understand who our audience is and who might be interested in the future in working with us. Hopefully I'm not blocking this. So our goal is to serve the community and provide an equal voice, foster a healthy developer community, increase adoption and awareness of XTZ, and to build a vibrant ecosystem of community-built projects. So here's a meme from one of our, it's kind of blurry, can't really see. So we are Tezos. You can fork a chain, but you can't fork a community. I think this is the greatest point, is that a healthy community is key to a decentralized network. You can fork pretty much any chain, but are you going to get the same development talent, ideas, and vision to drive it forward to make something, bring something to fruition? I haven't seen it, but so we primarily operate in North America and Europe, but our reach is global. We're trying to do more virtual programs, especially this year, and reach out. And Boston's been a big part of that as well. We've been trying to run meetups here regularly just to gather interest and bring people in. So currently, Tezos as a whole has 6 global foundations, 50 community groups, and 70+ community events. So we'll see a lot more, and I'm hoping to do a lot more online as well. The road to 1,000 new developers. This is more of a Tezos Foundation initiative, but we're trying to support it on our side as well. On the common side, we have Tezos Capstone and Zastron that we work with. Zastron is actually local to Boston. B9 Labs, the emergence of our Stack Exchange. If you are building on Tezos, you very much want to visit our Stack Exchange and participate. We have excellent help there, and we're continuing to grow. We are still in a beta, but I found myself using it more and more. And we are going to have our first hackathon in September, so we will announce a date for that. Ecosystem. So the ecosystem, I'll try to briefly breeze through some of this. I'm not the highlight here. So Tezos is thriving. There's an interesting website, tezosprojects.com. I don't know the last time it was updated, but we're continuing to try to build roadmaps, or not roadmaps, but maps of the ecosystem and projects and companies that are involved. Development, well, AJ put down that we have nomadic labs, but it's much more than that. We also have Cryptium, and we have, I believe we have development teams on 6 continents. I forget if that's right.
I don't know. I'm not sure there's something in Antarctica.
5, 4. We have many global teams. I don't have a number for that. Use case, this is sort of arbitrarily put in here. This is actually referring to the elevated returns announcement several weeks ago to tokenize about $1 billion worth of real estate. They also had some announcements in Singapore as well. Network, this is the most fun part. So currently we have 450 plus bakers over, okay, this is the stat I mixed it up with, over 6 continents. I guess Antarctica. So over 100 public delegation services, 50,000 plus roles securing the network, and 80% of the network is participating. At this point, we can also add in some stats for voting. The participation rate has been excellent. And here is, I don't believe this is the latest, but this is this is from December of 2018 though, by Galen. It's a nice overview of the wallets, explorers. As you can see, development, there's numerous teams involved. It is not just nomadic. We have some research, education, and content that continues to grow, as well as a changing and growing DApps, startups, projects around the new model that Tezos has provided. Governance. Tezos has the most advanced governance mechanism. Well, I would believe that it's a very conservative take on governance, and that it's limited to the protocol. It's not overextensive. And I think we'll discuss more about that when we currently have a collaboration project with the Tocqueville group to begin discussing how governance will evolve and proposals for amendments. So LPOS, liquid proof of stake is very fun. If you're not familiar with it, it's an extremely interesting consensus mechanism in that currently out of, I think we're close to 800, I think we're about like 780 million XTZ right now with inflation. And of that, only about 60 million are locked up in the most recent cycle. So it's a very liquid network in that it's not locking the user funds. These can be deployed at any time, and only the bakers are providing the bonds to secure the network, which shows that people are very involved and they're actively staking. I don't know the current staking rate though. It incentivizes and upgrades the protocol in the most efficient manner. Athens. Athens is probably the most interesting part of this all because we are a little more than halfway through the process. We finished the proposal period and we just passed on the exploration period, and we met quorum at 80%. And what we'll do is provide some links if you're not familiar with the governance stages to some articles, and there's also some really cool websites that have built out dashboards to show voting and the different stages involved. So I believe we have a test fork and one final stage involved. So proposal A, so effectively this first vote is extremely important. It's more of a litmus test on the network because people want to know if something besides fork-based governance can work, and can you hot swap code on a network, and is it just pure anarchy? So as sort of a litmus test, proposal A is to increase the gas limit, effectively allowing more Michelson code to run, and most of us are typically in favor. It's not supposed to be a contentious first proposal. And then there's proposal B, which also includes reducing the role size. So currently, in order to participate or to bake on the network, which is just network validation if you're familiar with proof of stake, you need 10,000 XDZ to be your own baker. And so currently, the leading proposal B is to lower that threshold by about 2,000. It will allow more people to bake and participate on the network. So we'll see how that plays out. And evolution. So we're slowly evolving. T-Core in Paris. So Tocqueville Group is based out of New York City, and we've been actively working with them. And I'm very happy to have them join the Tezos ecosystem. And so they are starting to put on much larger events. So we're going to see sometime in September, they'll announce a date for a major conference for Tezos, if any of you are interested. It's not too far off. And we also have the T-Core in Paris coming up. That's actually on April 18th, which should be fairly exciting. So it's kind of a quick and brief overview. But thank you for coming out to Tezos Boston, and I'm going to let Arthur take it from here.
Does that work? Yes. All right. Thank you for coming, and thanks Shaun, for the introduction. So this is going to. So I have a laptop with a lot of slides, and I give many talks, and I basically text the slides, and I grab a sample of them, and I put it in another deck. But you've probably seen a bunch of these online, and what I really like to do is kind of a choose your own talk type of things, because I generally know a lot less about the audience than the audience knows about what they want to know. And so I like to do Q&As in general, because it lets me go in depth into some aspects that people might be interested in that otherwise might not be covered in a talk if I just speak. There's basically three. I will just give a very brief overview of the type of things that are interesting to discuss. So overall, when people look at Tezos from a technological point of view, they come from three different angles. And a lot of time I'll hear someone say, well, I'm really interested in Tezos for this. The rest is like, I don't know. One of these legs is the smart contract and language security aspect, which is, hey, let's try to have a smart contract that encourages best practices in designing smart contracts, which avoids pitfalls, which avoid a lot of bugs. And it turns out that even though in theory you can represent the same, in all Turing-complete languages, you can represent exactly the same programs, the actual choice of the language in practice we know makes a difference in the type of programs that people write and the type of mistakes they make when writing those programs. So I think that a lot of influence can be exerted by the blockchain if it has a good default for its smart contract language. So that's one aspect that attracts people to the project. Another aspect is proof of stake. We're one of the first really major proof of stake network. The history of proof of stake systems is quite old. There was Spearcoin, there was NXT, which has been running continuously for a long time. But I would say we're one of the first networks to integrate some of the ideas around proof of stake around basically bonding and slashing of the bond. So basically reintroducing the economic incentive that you find in proof of work network back into proof of stake. And a lot of people got into Tezos because they were interested in proof of stake, and that was their that was the hook. And the third leg is governance. So, and I would say that probably one of the most important feature, but Tezos, because it's probably one that's going to be most defining over the long run. It's the idea that if you have a blockchain system, essentially you have to wonder, is that the best system we can build? Is there room for evolution in the system? And there's different school of thoughts in there. One school of thought is to say, let's try to get it as good as possible in the first try, and then never ever change it, because at the end of the day, stability and predictability is the most important thing. So we'll never change anything. And there's some value to that. But I think that this would be an argument that would make more sense maybe in 10, 20 years when most of the research on this has been done and we have a very clear lay of the land. It doesn't make as much sense today when there's so much discovery to be made. The other approach is to say we'll just copy the governance from open source projects. This is open source code. If someone wants to try something different, they can fork it. And as most people know in the Tezos ecosystem, there are game theoretical problem attached to that. There are practical governance issues associated with governance by fork. And the third idea, which comes from Tezos, is to say, well, let's use the blockchain itself as a means of deciding on its own evolution. So in some sense, blockchains are meant to represent a state that evolves around time according to operations. And in Tezos, we take the actual rules of the game, we take the rules of the protocol and we put that inside the state, and now we let people change the rules. Which includes things, changing the rules includes things like, let's stop changing the rules. You can, if somehow you convince that this is the best possible state of affair, it is a state of affairs that is reachable from the current point. I don't think it's desirable, but in theory you can move there. So most criticism of on-chain governance oftentimes focus on a single model and not really take into account the fact that the governance model itself can improve. So those are the three big aspects of I would say of Tezos. And one interesting area on top of that is, where do you go from there? Because Tezos launched in June of last year with most of these properties, and some of the interesting developments are going to be, so in the first category around tooling, so it's nice that you have a contract that facilitates formal verification. It's another thing to actually have an ecosystem of tools which actually lets you do that practically and deploy those contracts. The second thing is proof of stake. I would say that the proof of stake system for Tezos is probably one of the most advanced that you'd had in 2014 when this was all very new. There's been a ton of research and there are interesting development projects around improving the proof of stake system in Tezos. So that's also one area of interest for me, looking at what different projects are building and trying to find the right compromising. Where's the sweet spot for these things? And the third thing is also about governance and meta-governance, and how can we improve the governance system of Tezos, go beyond just coin voting, and also address some of the criticisms that have come around governance, such as the risk of vote buying, such as the risk of capture, and so on and so forth. So I'm going to open up. So this is just very brief lay of the land, and I want to open up to questions around those axes. See what people have to think. Yeah.
Yeah, I just had a question about. Do you see with Reason ML getting a lot of traction in web development? I mean, the liquidity project of Camel Pro already allows you to compile Reason ML to smart contract language, right?
Yeah.
Do you see that as like a what to bring developers in?
Yeah, so let me talk a little bit about that. So the fun thing is there's been a lot of time people say like, oh, it's hard to write smart contracts in Tezos because you have to write them in OCaml. And I say, no. OCaml is the language that Tezos is written in. You write the contracts in Michelson, or you can write them in a higher language like Liquidity, which is just like OCaml. But hey, there's a distinction. So yeah, Liquidity is a high-level language for Michelson. It basically looks like OCaml, and since it looks like OCaml, you can pretty much take almost unmodified ReasonML code and compile it to Liquidity, and so you can write your contracts in ReasonML. What I like in there is that what we've seen in one interesting avenue for smart contracts is what people have been trying to do with Ethereum and Web3 is really tying the interaction between the user and smart contract on a web page. And the idea is that you can use tools like Reason React for building web pages and at the same time write your smart contract in the same language. We know that's something that's been popular with Node. People have been very happy to just use one language to write their backend and then front end. And maybe that's something that can be replicated for writing an application, writing the front end of the application and writing the backend at the same time in one language. It also does not hurt that Reason and React are supported by Facebook. So Facebook has a lot of big dollars to throw after the development ecosystem for Reason, and so it's good to be to try to hitch onto that wagon.
Just to kind of follow up on that,
like to me, OCaml's always been like a very kind of niche language. Why did you guys select OCaml?
So yeah, OCaml is fairly niche, and one way you can see that is you go on Google Trend and if you look up for JavaScript and OCaml, you will see one line, which is JavaScript, and you will see a line at 0, which is OCaml. So that doesn't actually tell you that much. What you can do is you can look at JavaScript and Haskell, and you will see that JavaScript is about 20 times more popular than Haskell. And then you look at Haskell and OCaml, and you see that Haskell is like 20 times more popular than OCaml. So I would say OCaml is to Haskell what Haskell is to JavaScript. Like, this is squared. It's squared badness. So yeah, it's very, very niche. So that being said, here's what I think about it. Most blockchain development happens outside of the core protocol. It happens on top of the core protocol. It happens on all the applications which are built around it. It happens on all the layer 2 solutions, for example, on the distributed application. And none of that has to be in OCaml. And this is why, in particular, if you look at all the API, for example, of the Tezos node speak JSON, because you can interpret that with pretty much anything. So really, the knowledge of OCaml, and it so happens that currently the most popular high-level language for smart contracts in Tezos is Liquidity, which looks like OCaml. That's not my first choice for a smart contract language, but there are others which are being developed. There's one initiative which is SmartPy, which is basically Python, and it actually is like you actually are writing Python, like valid Python files, but which generate Mikkelsen code. So SmartPy is an interesting project. There's LIGO, which is also an interesting project. There's Morley. So there's a few projects which are coming out which are not OCaml based. So the question remains, what about the core? If you look at blockchain projects, they have generally not a whole lot of core developers, because it's not most core development is not something that is massively parallel, like developing an entire ecosystem. It's something that's a little serial, and so it's important to have, I would say, Tezos probably has more than many blockchain systems, probably because it has this ability of anyone to kind of come in and propose amendments, which is why more people have been interested in core development, and that's good. But if you look at a global set of people who are going to contribute on a core protocol, it's going to be, if we're lucky, it's going to be in the hundreds of people. If you look at even things like the Linux kernel, you will have a lot more contributors than that, but it will be a fat tail, and so that's going to happen no matter what. So if you were picking a language, let's say I build if you were picking a language for a platform and you wanted a lot of people to adopt it, then scale is very important. Having many people speak the language is important. In this case, I would say it's less so. I don't think it's going to be the case that people are like, well, I program in the Bubble programming language, and Tezos doesn't use Bubble, so I'm not going to program in Tezos. I think it goes like the other way. It's more of like, hey, Tezos is a really cool project. I really want to build something on Tezos, and then okay, you have to pick up some OCaml. But I would say an experienced programmer is the type of programmers that do core development. It's not a major hurdle to pick up a language like OCaml. I would say it's a bit of a commitment, but you spend 1 month or 2 doing exercises, and you know enough to contribute to the protocol. So, and most contributions to the protocol, they're also not that involved in terms of OCaml. If you look at the Tezos protocol, if you look at the whole Tezos shell, there's a lot of it which deals with the networking and the peer-to-peer layer and the mempool management, and that's fairly involved. That's a little hard. Then you look at the protocol itself, and all of a sudden, it's much simpler. You're not dealing with I/O, you're not dealing with concurrency, you're not dealing with any of this. It's much purer, and that makes it easier. The 2 nasty bits, I would say, in the protocol currently, they are in the storage functors, which uses a bunch of OCaml functors, so that part is a little technical if you want to change the way you store things. And the other part, which is a bit tricky, is in the implementation of Mikkelsen, which uses a lot of GADT, which is a way of doing more advanced type in OCaml. If you're not touching these 2 structure, and that's a lot. Like if you want to change the way votes are made, if you want to change, if you want to introduce different type of transactions, if you want to introduce new languages, all of that, you don't really need any advanced OCaml. I mean, there's like powerful changes to the protocol you can make where in the same way that most people learn to program, which is, you look at a program and you see a few constants and you see a few things, and it's really easy to make changes. So I don't worry too much about that. It's more of a perception problem at this point than I would say a practical problem. One concrete example is the good people at CryptoLiveLeak. They started out on Tezos. They came through the proof of stake aspect. Because they were like, hey, we want to be Cosmos validator, but Cosmos is not out. Let's do a try run on Tezos. And then it became successful. They're getting pretty successful at being validators on Tezos. And then they were like, well, can we do core development? And Adrian Bing has been picking up OCaml so that they can write their own amendment. So it's a bit of a barrier, but I think it's worth it given all the advantages of the language.
Can you touch on some of the security enhancements you Tezos recently?
The what?
The security enhancements. For example, particularly transactions.
I don't think there's been changes to the transactions in terms of security enhancements recently. Most of the security, if you're doing transaction, it really relies on key management, which is more of a client issue than a server issue. Yeah. And I have some ideas on that, but I don't think this is anything that has happened lately on Tezos. Anything else? Yes?
Does the foundation provide any incentives for people to develop on Tezos, or is it all community driven?
I mean, from what I can tell, I see a lot of projects, that start out building stuff, and then a few months later I heard they got a grant. So I know I do assume that yes, they provide this kind of service. But what's also really neat inside the Tezos is that if you are doing, first of all, there are many cases where you may just want to run a business and you use Tezos as your backend. So in this respect, the incentive is that you're going to be running a business and you're going to have a great blockchain to run it on. And the second thing is if you're doing core development, and that's one of the I would say one of the neater feature of the governance system, you can provide an upgrade and you can attach an invoice to it. So if you look at the Athens proposal right now, it has a very, very small invoice. It has an invoice of about 100 Tez, I think. So 100 Tez is about 800 million token out there. That's a very, very, that's one in an 8 million dilution. So very, very small, but I think it's just to show like, hey, if you want to attach an invoice, this is how you do it. So if you're someone and you say like, hey, I have this improvement that I can make to Tezos, and you can attach invoice. You can think of it in terms of like the percentages. Is this improvement to the network worth 0.1%, for example, of the network? And that actually, if you do the math, can provide pretty strong incentive for people around the world to bring the contribution. There's a whole wave right now of blockchain projects which are coming, which are based around one idea. In general, in this current wave, it has to do, there were two. There was one wave which was all about interoperability. So we had Cosmos and Polkadot coming in that wave. And Cosmos is shipped now. I think Polkadot is a little bit still out. And then there was a whole other wave which was like, hey, let's do consensus better, let's do consensus faster. And you see that with, for example, Algorand or Definity or all of these projects. And then they're all very interesting, but at the end of the day, I don't think you can, at the end of the day, I think these things survive if they have monetary premium. That's what gives value to this network, is being treated as money primarily, and that cannot be duplicated indefinitely. And so anyone sometimes has a new cool idea for an improvement, they're not going to be able to create a new form of money with it. And as a result, either they're going to try to enterprise solution, but I think there's some value to private blockchains, but I think it's kind of limited. Or they are going to try to launch something, but it might not work. And the third solution is to say, hey, I can contribute to an existing project, but I can also be rewarded for doing it. So that's the model.
So I have a question about interoperability
Yeah.
by the blockchain. So how do you perceive the Tezos ecosystem? Is it going to be towards that direction, or is it to be inclusive?
I mean, it depends on where people want to take it. At the end of the day, my own thoughts on the matter is, everyone. So I have my conspiracy theory. It's not really conspiracy theory, but I have my I would say it's my cynical theory on interoperability. The cynical theory is that, at least in 2016, 17, talking about competition was extremely taboo. right? You could not say that you were competing with another project. Even Ethereum, you know, they couldn't go out and say we're competing with Bitcoin. You know, they had a whole narrative. It's like, well, you know, Bitcoin is gold, Litecoin is silver. We're going to be gas. You know, we're a world computer. We're not a currency. We're just, you know, we're doing this very different thing. It's all complementary, right? And there was this Dfinity at the time was also saying like we're going to be a sister network to Ethereum. What does it mean? Well, we'll replicate Ethereum. It's like we'll be a sister. It's like we'll have the word sister in there. You know, don't worry. And Cosmos was going to hard spoon Ethereum. You know, fork is aggressive. Spoon, I mean, we just copy all the balances and we hope people come to our system. And lately, I think it's been more of like, you know, let's give, you know, I think on the Dfinity side, let's give money to all these other teams to move all their dApps to our chain and leave Ethereum. So now the whole like competition is taboo angle is gone. And I think that with Tezos, I embraced it a little too openly, and people were like, how dare you? Like, why would you even do that? So you had to pay lip service to a blue ocean strategy. And the perfect way of doing this is interoperability. You want to say like, what, you're going to compete with these people who are already so big, who have so much network effect that you're crazy? And you're like, no. I'm not going to compete with them. That's the beauty of it. I'm going to provide an interoperability layer for all of them to use my system. And so if they do well, I'm going to do very well because I have all this interoperability that everyone can use. And what you notice is that none of the, you know, if the Cosmos Hub is not a Polkadot parachain, and the Polkadot is not part of the Cosmos Hub. So it's like, yeah, I want interoperability as long as I somehow provide the backbone and the coin which is going to allow everyone to interoperate. So if a lot of people want to build a bunch of chains which interoperate and use Tezos for interoperating, you know, more power to them, I'm all for it. But I don't think it makes sense for Tezos to try to be a vassal of another chain.
Which is not going to be our, you know, it's not going to be your priority in terms of that kind of direction.
Well, I don't know. So the thing with Cosmos is that they have, you know, the whole Cosmos and Tendermint thing is nice because they have a pretty cool consensus algorithm. And the nice thing about Tendermint is that it makes it for a very, very efficient light client. So that makes it easy for them to port state from one chain to another. And that's the basis of the Cosmos Hub, which is to say everyone is going to port, you know, their own state to the Cosmos Hub, where they will be able to exchange states and then know about each other. What's not clear is that it's not clear why they have to go through a hub instead of just doing the exchange directly, but maybe the hub has primitive for doing all this. It would be fun to make Tezos into a Cosmos hub. You know, if there's going to be a bunch of Cosmos chains, it would not be too hard to add a layer of interoperability so that on the Tezos blockchain you can be aware of what someone is doing on a Tendermint-like chain, for example, if we wanted to do that. So, you know, you could say like Cosmos Hub, you know, how does that affect Tezos? Well, this is great, you know, they can all use Tezos if they want to communicate their state. So I would say, yes, you know, interoperability, why not? But as long as Tezos is a place where people interoperate with each other as opposed to trying to be underneath another system.
So I'm interested in, as an open source project that's decentralized, if you have a repo, you only have like a finite group of people that can actually merge commits. And so typically there's going to be regular like soft forks, I guess you say, or protocol updates that are coming through the official repo. And so how does that fit into governance?
Right, that's a good question, and that's particularly a problem, I would say, if you have informal governance, right? If you have informal governance and you can, where everyone can fork, there's still going to be a repo, and people might come to look at this repo as canonical and say, you know, well, you know, it's maybe github.com/Bitcoin or github.com/Ethereum or something like that, and there might be a tendency to think, well, whatever this repo does in terms of code change if they fork is probably the canonical version because it's a shelling point, right? It's a repo that has this name. So if you start adding on-chain governance, I think that greatly mitigates the issue because even if there's a repo which has a name which sounds canonical, and I'm aware that it's like gitlab.com/Tezos, even if you have a repo like this, at the end of the day, there's a strong protection of the fact that people need to actually vote for it and people need to actually have the governance procedure. So what determines the code base that runs on a Tezos node is not what you got from, it's initially what you got from, maybe from a repo, but then all the code updates are basically automatic. So if you follow the if you download Tezos and if you follow the blocks, you basically get all the upgrades. You download the code from the network. So the official, that's why you have every single block of Tezos has a hash of the source code of the protocol that it's running. And so that's why if you follow the chain, you'll be able to say, oh, at this point the chain uses that protocol, and at this point use that protocol. So it's not tied to a given repo. But I do agree that having repos can create shilling points. The thing is like if you want to decentralize beyond that, then you need to basically build something like a peer-to-peer GitHub or peer-to-peer GitLab, where there's no single repo, and then you take the existing popular website like GitHub and GitLab, and you just put nothing on there, and you put everything on your decentralized network. So that would be taking it one step further. But I think that just by having on-chain governance, you're already like way ahead of everyone by in terms of the control of these repos. Yes.
The question goes back to the commercial side. According to that announcement, I think they really restrict that to large-scale enterprise type of use cases, and I'm not sure whether you're aware of any, whether they would be willing to open that up to the general public.
No, I don't know what they're doing with their business. I'm sorry. I mean, the only enterprise thing that I've heard about is the thing you mentioned about the elevated return thing that came out, like the tokenization of real estate. But that's a different thing.
But Coinbase hired one of your engineers, right?
But they were,
No, they hired an engineer from Blockscale.
Oh.
he was a part of our community. He was a well-known baker. He was in our baker Slack.
So Blockscale, I mean, so I've met Luke a few times. Blockscale was this company that was providing scaling services for people wanting to run Ethereum nodes, or people wanting to run different nodes. And they got interested in Tezos, and they started running a bunch of nodes. And then they had they were contracted, I think, by the Tezos Foundation to run the bakers for the Tezos Foundation. So they had a lot of experience in this, and I figured that's why they got hired by Coinbase, because they had all this expertise in building bakers. Yeah.
Are you concerned that light baking clients such as BigChain will lead to decentralization of validators for the network?
That what?
Light baking clients such as BigChain would lead to centralization of validators for the network.
So you touch it. That's a very good question, because you could look at it two ways. You could say, well, it decentralizes. If you do light baking, you have more people bake, right? And there are more people who can withhold their signatures. So if BigChain becomes evil, you have a lot of people who can say, I'm not going to sign this blocks for BigChain. The problem is like, well, how much are they paying attention to the blocks that are being sent by BigChain? So if you look at decentralization in terms of like, what is the risk that the system gets compromised? And there's two ways the system can get compromised. You have a bunch of evil actors that get together and they form a cartel and they decide to attack the system. And another way is somehow people get hacked, people get compromised. So the idea of having many bakers have their keys in many different computers, from an operational security point of view, that's good. You don't have a single location where you can go and get the key. Now they're all running the same software. They're all running BigChain. So there's a bug in BigChain. Maybe the key could be taken, so that's bad. But maybe they're using ledger, so the risk is not so bad. Maybe you can compromise BigChain, in which case you can make them all signed by blocks, which is bad because then you can have an attack, but it's also temporary. You can pretty much detect that quickly, and you can probably react to that. So where in the balance does that? What in the balance does that do in terms of decentralization? I think it's hard to tell. But I would say it's definitely more decentralized. If you have to compare it to the alternative, and if the alternative is between using BigChain and between delegating to someone, then you get more decentralization with BigChain. If the alternative is between BigChain and running your own node, then it's clearly better to run your own node. So overall, I would say net positive, but these are very empirical questions because you have effects going in both directions, and it's hard to quantify them.
Yeah, this is a question more on the business side. I'm curious to know, how are you handling your competition? Your biggest rival is probably Ethereum. How are you handling them, or more to that story on that?
Right. So more on the competition. So when I say that, it was taboo to even talk about competing, I don't mean competing in the sense of your primary preoccupation is going to crush your opponents, because And that was the thing. It's like you say, like, well, I think we're in competition. It's like, oh, do you mean you want to crush them? Like, no, but it means that, yeah, yes, it's an expanding pie, but it's not an unlimited pie, and I don't think there's room for an unlimited number of blockchain projects. I don't really think of competition at this point because it's one quote from Paul Graham that my wife really likes and I really like as well, which is startups don't compete against each other, they compete against anyone giving a shit. And that's pretty much what blockchains compete against right now. The adoption of any of this is extremely low. And so I would say Ethereum's primary preoccupation and Tezos' primary preoccupation as networks and open source projects is making sure that they are providing useful tools, and they are providing tools that solve problems for people, and tools that are that people are able to use and are accessible to a large number of people, which we don't currently have. So that's a primary preoccupation. And then maybe 10, 20 years down the line, when there's massive adoption, and some blockchains have hundreds of millions of users, and some blockchains maybe have 300 millions of users, then maybe at this point you start thinking like, like if we want to get more adoption, they're going to have to get less. But we're absolutely not there, and so it's a bridge that can be crossed down the line. And or maybe in 20 years, there's no blockchains because people have decided that actually it was all a silly experiment, and none of this matters. But I don't think that's the case, but at any rate, I wouldn't say that there's active. I wouldn't say that competition has to be ferocious at this point.
I have a question about the adoption that you mentioned. So in the business side of component of adoption, right? So the business merchants, for example, they have their own consent system. Is Tezos going to be facilitating that kind of adoption wherein these merchants, these businesses will be utilizing the ecosystem, the Tezos ecosystem, to use that as a platform for them to transition?
To transition from?
Transition from the traditional accounting system, the reporting side, because these businesses, even for example a small business, they want to adopt the blockchain using Tezos platform, but then they still have the reporting side obligations to IRS or the taxes and stuff, right?
But
the accounts payable, the taxes they're paying. So how does the transition? How is it the Tezos responsibility on facilitating that kind of transition from the users?
I'm not sure, but I'm happy to report that even if you use a blockchain, you can still report what you're doing on a blockchain to the taxman, and it's probably wise to do so.
There is a production kind of solution in that case. Are you aware?
I don't know. I mean, just like from personal experience and talking to people, I guess like even just if you're just looking at cryptocurrencies, like people buying cryptocurrencies and selling cryptocurrencies, they really struggle in understanding how to file their taxes because there's a bunch of questions that exist. And Coin Center is doing interesting work on a topic that haven't been solved, on like how the tax treatment of many stuff that happens in cryptocurrencies, like forks and so on and so forth, is still unclear. So I guess there's probably business for people building tax accounting software that are aware of the stuff happening on blockchains. And I suppose that if you're a business, you would probably need those, and you would probably need those software as well as something like accounting software that's aware of this. Other systems. I remember a time where people, that was I guess 2014, these memes go in waves. There was a whole thing where people wanted to redefine Bitcoin to have 2 decimals as opposed to 8 decimals for compatibility with existing accounting software. That was a big thing. I've since been convinced that probably the best way of I gave a few talks in Korea and Japan, and just using the money there, there's basically no point in having cents because the small denomination is close to 1 US cent, for example, and just dealing with integers is just infinitely easier. So especially for implementation. So I actually kind of like that. But back to your question, the answer is I don't know.
Because for example, PayToNet, right? They have this wallet kind of, they have this use case where you have a POS where people can go and buy and pay the POS.
Yeah.
Behind the POS, you still have to gather your report and your income. Like you have to pay your the supply chain, like your supplier, there's some sort of obligation from the current environment and business environment.
No, yeah, absolutely. I think it's potentially a business opportunity here. I mean, you know, just doing my own taxes, I had to do my own taxes, I had to program something to basically come through files and actually compute the stuff. So there's definitely room for software here for like just like individuals and enterprise. Yeah.
Hey, back to the adoption. What you said was that you're focusing on providing tools that will ultimately solve problems, and you were talking about the competition. It's kind of the same thing, right? The blockchains need to, in order to go mainstream, need to figure out how to solve meaningful problems in a better way.
Right.
My question to you is, so down the road, what are the primary problems that you expect Tezos to solve, and how does that guide what you're doing today?
That's a great question. So here's the way I think about it. I have my own view on what I think this type of systems can solve, but they are also fairly generic, and there's no necessarily need to close any door just because you're saying that, oh, that's not going to be an application. So if there's no trade-off in allowing certain type of applications, then you might as well make that possible, because you never know, right? And bearing that in mind, here's the things that I think are. I'll tell you first about the things I think are not too important. So I don't really like the world computer meme, the idea that you're going to run all this computation, and that if only we had just more throughputs, and if only we had more scalable blockchains, we could all run our computation, and we can run essentially programs on a blockchain, because I believe that most programs have no real reason to live on a blockchain. At the end of the day, what a blockchain does is I think what it's mostly useful for is representing a cryptocurrency, and what your programs are going to do at the end of the day is moving that from one hand to another, right? And in many cases, the only thing you need is to know the outcome of something and to process that event, as opposed to running an entire computation. So I would say that a lot of this stuff probably should happen off-chain and not on the blockchain. Here's another thing I think is not too useful. There are a lot of people who saw the idea that, oh, in Bitcoin you can trace all transactions. There's a trace of transaction. If you look at the coin, you can see all the steps it went through. And they were like, well, that's interesting, because we want traceability for other things. And since there's traceability of coins on Bitcoin, we can use traceability for other stuff. And first of all, the traceability of coins on Bitcoin is a bug. It's not a feature. It's because building Bitcoin without this traceability is really, really hard. The best way that's been found so far is to do what Zcash is doing, and that's really, really advanced math and cryptography. I have almost no doubt that if Satoshi Nakamoto had a way of doing Bitcoin without traceability of the entire Bitcoin, that's how it would be done, based on the fact that they were convinced that somehow not reusing addresses and using this TX on and TX out system could provide some anonymity. So that's the first thing. And the second thing is, the thing that's interesting in representing in a blockchain is things that can mutate. So you might say, what do you mean? The blockchain is immutable. The whole point is immutability. No. The point is mutability. You want to represent a state that changes, because if you want to represent something that's immutable, you don't need consensus. Let me give you an example. If you look at data structure that you use in a program, you can divide them in two categories: append only and not append only. So an append only data structure is you have data and you just keep adding data to it. Right? So for example, a linked list. I have an element and then I add more to it. And in practice, a linked list, much like a blockchain, is not really a list. It can be a tree, because you don't have a guarantee that you're always going to add at the end. So a linked list, which is in practice a tree, is an append-only data structure. A tree is an append-only data structure. Here's a data structure that's not append-only, a doubly linked list. Because if you want to add an element, you need to modify a previous element. You need to have a mutation. You need to change something. A graph is not append-only. So if all you want to represent is append only, then you don't need a blockchain. What you need is a decentralized database. You just send out all the data on a database, you put all the data out there, and if someone wants to see the data structures, they just grab it. It's when you want to change something, because if you want to change it, you want to change it one way, you don't want to change it two different ways. You want to have some sort of unicity, and that goes to the heart of the double spending problem. What you're trying to do on a blockchain is have a mutation. You want to say, this coin belongs to someone, now it belongs to someone else. You don't want to have a structure that says, and it could have been sent to this person, and it could have been sent to this person. And pretty much the same goes with traceability. If your application is, I want to put lettuce on a blockchain to see if there's no E. coli on it, and that's a real application. It's a real IBM thing. First of all, there is no international government conspiracy trying to shut down your system, trying to track lettuce, and frankly, that's what a lot of the blockchain stuff has been built for. So what your solution, first of all, is way overkill. Second, you don't have a mutability problem because you have to trust the person signing that the lettuce went from A to B, right? And so if you have a double spend, if the person said, I loaded the lettuce here and I loaded the lettuce here, you know he's a bad guy. There's no problem because you don't have the problem of saying, oh, I accepted the payment, I know this happened, I know that happened. No, you don't have this. So you don't need the proof of publication, maybe you need timestamping, but you don't need a blockchain for any of this. So I don't really believe in all this traceability use case. That being said, someone comes to me and say, you know what, I heard what you said about the lettuce, I think you're wrong, I'm convinced that this is great, and I want to pick a blockchain to use. By all means, use Tezos, great blockchain. But just because I don't think your use case is going anywhere doesn't mean you shouldn't build it on Tezos. So that's just my point of view, right? I'm not going to close any door. Now, what do I think has value? Well, what has value is basically representing things that are going to change hands, because things that are going to have mutation. What are those things? Cryptocurrency, we know that's a thing. Representing assets, so tokenization of real estate, tokenization of equity. For example, I own it, boom, I give it to you, now you own it. Name registries, so DNS, I have a domain name, I change it, you have a domain name, so representing keys and identities, all of these sort of applications. Now if you go beyond that, you say, okay, I have property on the blockchain, I have smart contracts, what can I do? Hey, I can have programmatic properties, so building insurance services. It's a new narrative that has become known as DeFi, and I'm a little sad because now Ethereum is has reached the DeFi narrative, which I think is probably the correct one. So they finally hit on the right thing to build. For me, that's the thing that makes the most sense and is the most useful on blockchain, and that's probably where it's going to go. Especially in terms of if you're looking at how decentralized you need to be, how strongly protected you need to be. A lot of dApps don't really need to be on a blockchain. It's convenient, but they don't really need to be there. They don't really need to have decentralization. And I think that probably Cosmos is going to eat a lot of this don't really need to be decentralized dApp, because if you're building your dApp and you're on a blockchain and like, oh man, I'm going to have to share the gas costs with everyone, it's going to be expensive, and maybe the blockchain, maybe they're going to change things on the blockchain. Wouldn't it be just easier if I just launch my own blockchain, my own rule, and sure, I'll be decentralized, I'll have like 4 computers, whatever, do this chain, and then I'll be able to port the state somewhere else, so it's interpretable, that's great. So for all of these dApp markets, and I'm talking about the type of dApps which have been very popular on Ethereum circa 2017, I think projects like Cosmos are probably going to eat a lot of them, and the ones which are going to stay are the ones which really need to be decentralized, because there's a lot of value at stake. There's a lot of, you need to have a very little trust. We're talking about the use cases, and I was saying essentially blockchains are good for mutation, so anytime you need to transmit something to something else. So basically representing property, but property in a broad sense. It could be like very, very crudely a cryptocurrency. It could be some external assets. I think the case where external asset is there, it's a little weaker because you still have to rely on some sort of trust, but it's still there. Mostly for convenience, and representing rights. So it could be a right to a name, it could be a right to access something. Again, it gets a little weaker. I think honestly the strongest case is for cryptocurrency. It's kind of funny is that Bitcoin came out and everyone was like, okay, oh, we can do cryptocurrency. What else can we do? And this was not just people who didn't like Bitcoin. People who liked Bitcoin. It was a big meme. It was money is just the first app. You remember that one? Money is just the first app. So I think money is the most important app by far. So the money aspect has been underhyped, and I think the other aspect has been a little overhyped. So I think that's something that people in the Bitcoin ecosystem get, the importance of money, a store of value. I think they're a little too married to the ideas that somehow, since Bitcoin is what it is, you don't need smart contract, you don't need any of this, none of this is useful. And I think if you're going to have decentralized money, being able to have decentralized escrow around it is a very powerful thing.
I'd like to make a follow-up about mention about privacy. So how do you foresee that in Tezos ecosystem? Is it going to be, are you looking at into the zero knowledge algorithm or cryptography implementation?
Yeah, so privacy. I think privacy is pretty important. Privacy is very important if you want to build something like eCash. It's you know, if you look at the original dream of before Bitcoin, you know, people want to build eCash. They want to build something that's just like cash. So cash doesn't have an intermediary. You know, I have cash, I give you cash. It's anonymous, and you control it yourself. And we have two of these aspects with. With cryptocurrencies like Bitcoin. You are, you know, your own bank. You're your self-custodian. You can really control it. People can, you know, if people want to take it from you, they have to really take it from your hands. That's pretty strong. They don't have to just convince some big player who's going to go along, who's going to roll over with anything to just like take it from them. So that's pretty big. It also has the ability of paying anyone. And the nice thing, if you compare cryptocurrencies to cash, is that you can pay people at a distance. It's never been possible in thousands of years of history to pay people at a distance without either a very dangerous travel or without intermediaries. So for the first time it's possible to do that. It's pretty cool. But we don't have the anonymous aspect, and so I think it's pretty fundamental to respect people's privacy when they transact online. And there's several arguments for privacy. You know, of course, the usual thing against privacy: if you're doing nothing wrong, you have nothing to hide, right? And that, of course, assumes that that the people who might go after you are necessarily virtuous, and that's not the case. You may be worried about kidnapping. You may be worried that you live under an oppressive regime, and people might go after you. And so there's all sort of valid reasons for wanting to have your privacy. There's also a concept of human dignity, just like being able to have your own private life, not having everything exposed to everyone is important for dignity. No one questioned the fact that you're allowed to go around wearing clothing and not have to expose yourself naked everywhere. No one says, well, you know, if you have nothing to, if you have nothing to hide, you have nothing to fear. It's ridiculous. It's about dignity. And in practice, there's so many others. You know, you're a business. For example, Apple as a business is very secretive about some of its contractors because they can have small contractors, and if people knew about this, maybe they could seize some supplies, they could like try to buy out the contractors and so on and so forth. So you're a business, you're making transactions, you don't want everyone knowing about all your transactions. So just like the business case for it is very, very strong. So how do you get privacy on a blockchain? Well, that's difficult because the entire point of a blockchain, the entire solution to the double spending problem is say, hey, you're giving me a transaction. How do I know that you have not made this transaction with anyone else before? And the way you do this with a blockchain is to say, well, all the valid transactions have to be on the blockchain. And if it's not on the blockchain, then it didn't happen. It's more than timestamping. It's not just ordering transaction. It's a proof of publication. You show that if my transaction was not in a blockchain, then it didn't happen or it didn't count, right? That's very, very strong. And so, but it's radically opposed to privacy. You basically have to put every transaction in public view of everyone. So that's a problem. And the solution with zero knowledge proof is essentially that Zcash takes, for example, is to say, well, you know, I have some money, but I don't want to reveal anything. And so what I'm going to do is I'm going to prove that, you know what, at some point I posted some information on a blockchain, and that information proves that I didn't spend this money. But all I'm going to prove to you is that there's no conflicting transaction in this blockchain, and that's the only thing I'm going to prove to you. And that's the best privacy you can get. Like you cannot get more than that. Like that any other system is going to have slightly weaker properties. So if you look at something like Monero, for example, you get some pretty good obfuscation, but there's still things you can do. So I'll give you a concrete example. Let's say that you are, let's say for example you're using Monero. So amounts are hidden. And transactions are obfuscated because you pick maybe 5 different UTXOs to make your transaction. And I'm a journalist. I live under an oppressive regime, and I have a source that's giving me information. I have to pay sources. And so there's someone who's suspected to be a leaker and who's suspected to be selling information that's helping maybe political dissidents. And so what you do is that you're an agent of the evil and corrupt regime, and what you do is you go and you make one payment to that source. So and then you make another payment to that source a little later, and then you make another payment to that source. And now you also control an exchange, and you see the source basically sending their tokens from an exchange to the other. And since you control the exchange, you can see, hey, on the same account, you had transactions which all included the UTXOs, which are known to be tainted. So if you do that, you can de-anonymize someone. Now, it's an active approach. It's not just like I'm passively monitoring the blockchain like it would be in Bitcoin, and I know this. You have to actually trick someone, but you can still do it. So the best privacy you can get is if you have something like, I would say like Zcash. It doesn't, so there's some scaling issues around it. The main one is that if you want to have a large anonymity set, your set has to be growing forever, right? Because if at some point you say, hey, that person who got some token at some point, they no longer have it. Well, it means they spent it. So you have to keep instead of having to keep all the accounts on the chain, you have to keep a history of all the anonymous transactions that have ever happened. You can weaken that a little bit. You can say we're going to just keep the last year of transaction, right? So you lose a tiny bit of anonymity in doing so, because now because now you say, well, you're sending me money. I know that I know that this coin that have been spent, they came about in the past year. They have been spent in less than a year. So you get to know that information, but it's very, very weak. And so that in practice, that kind of solves the problem. In terms of integrating that in Tezos, so the Zcash team has done a pretty great job at building a circuit for doing this in sapling. They used to have a circuit that was taking about a minute to generate proofs, and now it's down to 2 seconds. So it's pretty practical to have this in wallets, even though integration remains limited to this day. I'm maybe one of the few persons who've actually done transaction on Zcash and not be a miner, because I wanted to test out the system. And if you do it from the command line, it's not it's not necessarily that easy, but it works. They have a very nice library for doing this. It's a Rust library. There are bindings for this library that exists now in a camel in one of the Tezos repo. So it's really a matter of putting it in a protocol. And I think the thing that makes the most sense is not to try to change the way that Tez is being sent around, but rather to offer a primitive in smart contracts. So you create a primitive in smart contract, a new opcode in Michelson that says, hey, so the data structure you want to maintain is a set of nullifiers, which is all the transactions that have happened. You want to maintain the tree of commitments, which is all the commitment nodes that have been created. And then you want to have a type of object called a proof. And then you say, okay, here's the proofs that I moved something around in this thing and produced these nullifiers and it's correct. And here's the proofs that at some point I put some money in there and it's out there. So if you do that, the nice thing is you can build subtokens, what you would call in Ethereum ERC20s. You can build that and have the properties that they are going to be, that they're going to have the same privacy protection that you would have in Zcash. So of course, one of the things you can do is you can wrap a Tez. So you could just have a contract where you send one Tez, you get one Tez in the balance of the contract, and you can do all sort of transactions with it. So you can have all the Tez inside one contract as opposed to doing protocol wide. But you can also do it with anything. So if I want to start a token on Tezos that represents I don't know what, you can have the same privacy properties. So it's kind of neat to put it in at the smart contract layer. Yep.
How important do you think is it to implement or to create alternate implementations of, say, the Tezos node or shell?
So hey, that's a good. So there are two parts to Tezos really. There's the shell, which basically all the shell knows is, hey, there's such a thing as blocks, and there's such a thing as operations, and things as like chain and times, and I have peers, and I hear from my peers about certain blocks, and then I reorganize those blocks, and I talk to a protocol. We call it a protocol in Tezos, and sometimes it's confusing because you say protocol, people think communication protocol. I'm tentatively trying to rename this rule set. We'll see if that catches on. So you have a rule set. So the rule set tells you how to interpret the blocks, what to do with the blocks, what chain to keep. But the shell does all the rest. And I would say that most of the complexity and most of the difficulty in building Tezos is actually to figure out exactly where the frontier is between the shell and the rule set, where the abstraction is. If you look at the paper in Tezos, it says, well, the only thing you need to abstract are two functions, apply and score. That's true in theory. It gets fiendishly complicated if you only have these two functions for efficiency purposes. So one function you might want to export is, okay, maximum block size. Because I don't want to get a block that's a terabyte, and then, okay, my shell will accept a terabyte block, and then it will ask the protocol if that block is valid or not. No, because you've already wasted all your time. So there's two ways you can fix this. You could say, okay, our function is going to be streaming, so when I get a block, I stream it to the rule set, and the rule set will stop me at some point. But it's a lot easier to just say, okay, so you export apply, you export score, and you export max block size. And in practice, I think today the protocol exports maybe a dozen functions as opposed to just two. But they're fairly limited, and the idea is you want to cut as close as possible to the protocol while keeping an efficient shell, and that can be a little difficult. If I had to say the ugliest leak in that interface is a thing called transaction quality metric. So basically, when you have transactions that come in your mempool, you don't know what fees they are, and only the protocol can tell you what fees they are. But you have to decide if you're going to put them in your mempool or not before that. Without having to execute them. You don't want to execute them, especially if there's a smart contract. You want to see what the fee is. And so there's a thing that the protocol exports, which is transaction quality metric. And what it does is that it takes a transaction and it returns to you a value which quantifies how good this transaction is. And in practice, it's how much fee there is to the transaction, right? But it doesn't have to be that. It's generic enough. So I would say that's probably the ugliest bit in the interface. Now back to the question. If you wanted to implement a different Tezos protocol, there's two things you could do. One, you could implement a different shell that hosts the same OCaml interpreter. We'll talk about that in a second. This other thing you could do is say, I want to have a different interpretation of the OCaml. that one's a little tricky because the definition of a protocol of Tezos is an OCaml code. So you could do that, but then the minute there's a change to the protocol, you kind of need to catch up, and you kind of need to catch up. That's not necessarily great. The benefit of just doing a change in the shell is that you get to have a different implementation, so you get to have some resilience in your network, but the part that's consensus critical is not going to risk to fork. So one of the issues sometimes with multiple implementation is the idea that, hey, what if they disagree on the validity of the transaction and all of a sudden our chain splits because of that? And that's pretty bad. In some sense, it might be worse than having one version and just going in that direction. One of the reasons, for example, you don't see something like floating points operation in Michelson is that even though they are very well defined by a bunch of standards, there's still a risk that some processors are going to run something slightly different, and the standard is murky enough that it's not really something you want to touch. So I like that, and there's some effort. I know that Uri has been working on a Rust shell for Tezos, so that's pretty cool. If at least, so that people who say like, oh, Tezos has to be an OCaml, there's only OCaml in Tezos, like, nope, no, actually there's Rust. Here you go, there's different implementation. So just for making that argument, it's fantastic. But also it means that more people are aware of the architecture of Tezos, and more developers are aware of the protocol, more developers are aware of the system. It may also attract Rust developers. You're a Rust developer, you say, hey, you know what, I want to contribute to a Rust open source project. I really like Tezos. Boom, here's some code I can contribute on. And hey, hang on a second, what is this interface with the protocol? And now I'm learning a little bit about the protocol. So overall, it's probably a good thing. I would say that if you're running really Byzantine fault-tolerant algorithm which strongly favor finality and safety over liveness, one of the nice things you have is, well, if there's a disagreement in the chain just stops. So you don't have the fork into two chains. And that's a pretty cool property. Although I do think that, I don't know, I still like solutions which can reorganize and recover from liveness failures automatically.
So my question about storage.
Yeah.
I'm interested in reducing database size since I'm running delegation service.
Yeah.
So I have two questions for you. Can you describe in details Iron test release, what they have done differently? Would you recommend to deploy this release? And second question, it's about moving entire database into memory. I think you talked about it a little bit, that we're going to move entire database into memory. We just need to increase the database size up to 16 gigabit or something, right? Yeah,
so let me talk a little bit about it. Let me give a little bit of history on the Tezos data format. So originally Tezos uses a project called IRMIN in order to store data. And IRMIN does a lot of things, but what it was used for was basically storing the information. And when you store information in a blockchain, it's useful to store it in a Merkle tree structure, because then you can make proofs about your state. One of the things that's famous for missing in Bitcoin is there's no commitment to the set of UTXOs inside blocks. You only have a commitment to transactions. It would be far easier to build light clients if you had a commitment to the set of UTXOs in every block. Most Bitcoin developers are very conservative, but it's one of the things that they will agree about, which is like, yeah, it would be nice if we had this. So Ethereum does it. They basically have what they call a Merlix tree, because they like inventing new words. But and in Tezos, the way this was done is basically use Git. So Git, a Git tree is a Merkle tree, and Airman lets you use Git representation for storing data, and that's neat because it comes out of the box. You don't really have to think about it. Boom, you have this. It gives you a commitment hash, very easy. And originally, this would run on a disk, so it would represent everything as directories in your operating system and as files. So you would imagine that where you went down, the hash of a contract, it would go byte by byte and create subdirectories and then put inside the file the information. And for a long time, if you ran the Tezos testnet, you could go in the Tezos data directory and you could type git checkout, and you would actually get all the files representing the current state of the system, which was cool. Then we got rid of that because we didn't want to use SHA-1, because it was collisions on SHA-1, so it became another hash functions. And the other problem was that this was consuming a lot of inodes. So when you have an operating system and a file system, your file system represents, it has little indices for files, and it kind of assumes that you don't have too many files. But you ended up with thousands and thousands of files, and the file system didn't like that. It's not made for that. So one solution would have been to say, well, install a different file system. There are file systems which are better suited for dealing with this, like BetterFS. So that would be one solution. And the other solution was to say, well, instead of writing our files on disk, let's move them to a key value data store. And many blockchain projects use key value data stores like LevelDB or LMDB. Tezos started with LevelDB and then moved to LMDB. So the idea is that it's every node you have in Git, instead of writing it as a directory or a file, you take its hash and you put it inside LMDB. And so right now, when you're writing something in Tezos, basically you're going to look at the hash, go down the LMDB tree on disk, find where in the LMDB tree it is, then that will point to a Git node, which will point you to the next one in the tree and go down. It is extremely inefficient. On top of that, almost all of the code for the node in Tezos is written using LWT, which is an asynchronous framework, which lets the node do a bunch of things while it's retrieving things on the disk. When that moved to LMDB, all of this code became blocking. So the storage is far, far less efficient currently than it could be. So that's part of the problem. And on top of that, the storage keeps all the history. By default, it used to keep all the history of all the intermediate states that you went with. And so you had a storage that took a ton of space on disk. Since the LMDB database was bigger, the trees were deeper, and so you had to make more disk access to get it. And so I/O has been really, really one of the bottlenecks for Tezos. So what are the solutions here? Well, one thing is, first of all, stop keeping all the history of all the intermediate states. That's what Ethereum calls an archival node. We call it as well an archival node. There's really no point in doing that. I totally get keeping the history of blocks because, hey, you want to be able to show that, what happened exactly and where we got in that state, but you can discard the other one. So you just keep the block, discard the intermediate state. The terminology for that is a full node, and there's a branch that you can already use that will run a full node. And I think a full node right now runs in a couple hundred megabytes, as opposed to running in tens and tens and tens of almost 100 gigabytes. The funny thing is that, when this came out, a lot of bakers were like, you know what, I just bought a terabyte SSD, it's not that expensive, I'd just rather keep on the SSD and not have to worry about even stopping my node. So we're like, but the benefit is not just more size, it's also that it's faster, you do less disk I/O. Now what IronTez did, on top of doing that, is that they moved away from LevelDB, and instead of that, they just basically took the Git tree and wrote it directly on disk. So it's basically a way of saying, okay, we know exactly the structure we have. We're just going to allocate a large file on the disk. We're going to mmap it, which is just like map the file in memory, and then just like write directly into it. And if you do that, you're losing, you have the benefits of LWT. You're losing all of the overhead of NMDB, so obviously it's going to be a lot faster, and also is going to have a lot less overhead in storing. Whether or not to use it, I would say, yeah, I would suggest using it for test networks, for the AlphaNet, but it's fairly immature. I think it's more of a proof of concept than something you might want to use in production. So while it's still immature, I would say test it, play with it until something along those lines is has been more tested, would be probably a good idea. I've been working on my own on a project which is a little different than that, which basically gets rid of the Git structure. Because the problem with the Git structure is that if you want to make light client proofs, they're kind of bulky. If you really want small light client proofs, you want basically a binary tree. And so I've been building a library for doing efficient binary partition trees in Tezos to replace Airman. And that one, which also includes the garbage collection. So that one should be pretty efficient, but it's still a work in progress. If the two things that I've been really keeping an eye on personally on the technical front has been making the consensus, making finality in the consensus faster. I think that's important. People are going to see a lot of networks with fast finality, and they're going to say like, hey, hang on, why don't we have that? That's really important. I also sometimes hear people say, hey, this is so fast. You get transactions in 1 minute. No, you do not. Please wait confirmations. If you're looking at Tezos transactions. So having faster finality and also having much better I/O, because it's really been the bottleneck. As far as getting the I/O into memory, so first of all, this kind of already happens. If you have a bunch of memory, your operating system is going to cache all of this disk on your memory. So as you access the disk, it's going to be cached on memory, and your operating system is not going to go all the way to the disk every time. So this kind of happens by itself. You don't need to do anything special for that. What I've been thinking about is, in some sense, when you pay for gas, you pay for a computational resource that's limited, and gas is just one abstraction. And also storage cost is one abstraction, but you can, if you model something that's closer to the machine that people are actually running, you can get something better. So imagine a model where you have two types of storage in smart contracts. You have deep storage and hot, maybe let's say, I don't want to say cold storage because people think about keys, so let's say deep storage and shallow storage. So if I put data in deep storage, it doesn't cost me that much, and typically the node will basically take everything that's in deep storage and store it on disk. If it's in hot storage, then the node by default keep it in RAM. Now, when I run a smart contract, you could say that the smart contract can only run on data that's on hot storage. Now, as a node validator, that gives me the guarantee that whenever I run a smart contract, it's only gonna, I can have a very high gas limit because I know that I'm not doing any I/O, right? If I'm not doing any I/O, if all of the stuff is in memory, it's very, very fast. But how do we get from deep storage to shallow storage? Well, then you have then you pay a high gas cost. So basically, you would have an operation that says, I'm moving data from my deep storage, like you go to get all the way on disk, and moving into memory, and then you can use it, and you have to pay a higher price for this. So if you were to do, the problem is that right now you need to have a one-size-fits-all system where people have to pay gas. And they have to mix it depending on whether people keep it on a SSD or a magnetic hard drive or on RAM. It's going to cost the same way, so it's kind of a murky cost. You would want to have a two-tiered cost for storage and for gas. That makes it more efficient. Now you can go even crazier. You could say, well, actually, we'll have 4 tiers of storage. One is going to be stored on tape. One is for what you store in an SSD. One is for something you store in RAM, and why not, L2 cache, N1 cache, you can map the entire architecture of the machine on a gas system and have something more efficient. At some point it plateaus because, we're not building, we're not going to run printing and folding on this thing. One thing I said this morning in my talk was I don't really believe in the world computer, but I do believe in the world spreadsheet. So, if you run a spreadsheet, you don't need to have that much, you don't need to have that much computing power. I also strongly believe in that a lot of applications belong on the L2 layer, so we cross that bridge when we get there. Yes, and yeah.
I was just wondering, because your Tezos is written on Camel, have you looked into using a Mirage OS unikernels?
Yeah, well, actually, Airman is part of the Mirage OS project. So yeah, absolutely. So what unikernels do is you run an application on a machine, but then you have to install all this operating system, and you don't end up using most of it. And so the idea of unikernel is to say, if I'm just going to run one web server or one application on the machine, why do I have to run all of these other services? They take resources from the computer, but they're also a surface area for attacks. And it would be very cool to basically take a Tezos node and compile it to a unikernel. There's a ticket for that in GitLab where you can say, I have this node and I just transform it into an operating system. I just put this on bare metal, and now there's nothing else but the Tezos node that runs on this machine. So there's very little surface for attacks. If there happens to be, I don't know, an exploit in ping, then it doesn't work because it's not even running ping. It just runs this thing, and it's more efficient. That said, it's out there. If there's some people who want to pick up this project, it's a fun project. I think that if you're a programmer and you want to do this, unless you really, really want to do this, there's more low-hanging fruit of cool stuff to do on Tezos, but that is definitely a fun one.
I think we're running close on time here.
Okay.
But I have one more question.
Oh, I had one question here.
Sorry, this is a super non-technical question.
Yeah.
Where does the name Tezos came from, and what is it all about? Sorry.
Well, the ancient Greek, they would maintain cryptocurrency ledgers, and they had a word for smart contract, which was Tezos. And so the official answer is that Tezos means smart contract in ancient Greek. Yes.
This is also a non-technical question, but I think, so Tezos kind of came on my radar probably 2 years ago this month, I think, as it was ready for an ICO. And I remember my son kind of introducing me to it, saying he wanted to put his life savings into it, but...
Do not do that.
I think it was 2 years ago today, so
okay.
Not this month. But my question is, I think you were working on it before then, so if you kind of look at the scope of the project from its inception till now, like maybe what are you most proud of that's happened within the Tezos ecosystem, or what it's done, and maybe what are the biggest disappointments that you've seen during the project?
Oh, I think the thing I'm most proud of is like how big how the community has sprung up after the launch. One of the things that I was a little initially worried about is, there was a testnet for a very long time. The Tezos testnet ran almost continuously from February of 2017. You could connect on the Tezos network, you could use it, it was functional. But there were very little bakers who were actually using the testnets. And there was basically MyCryptoDelegate and Tezigator, and they were the only two on the testnet. Very late, there was XTez, which is infamous for basically just like launching a big operation and then disappearing and never know. It's weird because they were very active on the testnet. But I was kind of worried about that. I was like, well, what if there's only a few validators? And as soon as the network launched, immediately there were a ton of bakers that sprung up, and we ended up with a very decentralized network of bakers, which are very local, which have their relationship with their delegators, and I think that's been fantastic. So I would say that's one of the things I'm most proud of is the community that's sprung up around it, and not just the baking community, the developer communities that people have met through this have been pretty awesome. So I would say that's the thing I'm probably most proud of in the system. The thing I would be least proud of in Tezos, let's see.
In terms of like expectations.
Disappointed. Let me think. There's just so many things, How to pick. I want to give a thoughtful answer, so let me think a little bit. I guess I wish that when Tezos came out, it had a more developed ecosystem for building on top of the protocol. So, I think Michelson is a really, really strong base, and I personally like writing contracts in Michelson. Small contracts, if you want to write bigger contracts, you basically need to do Michelson metaprogramming or to have a higher level language. And I wish that when it came out, it had more of a more tooling for developers to build on Michelson, because I think the tools for baking were simple enough and useful enough that many people were able to bake. Even people who never used a command line before became bakers, and they were saying, like, okay, I get it, you type these comments, and there you go, you're baking. So that was great. And if something like this had happened, I guess, on the development side, I think maybe it would have captured a little more mind share among developers building on this. I think that's something that's like progressively happening, but I would say that's maybe something that would have been good to focus on a little more earlier on, especially since, one of the benefits of Michelson is in facilitating formal verification, but you still need tooling to do that. And some of the tooling is coming. So there's been a COG verification of the multi-sig contract for Tezos. There's a COG embedding, it's Micho COG project that exists. But it would be cool to have a lot more automated tools, tools using SMT solvers, special DSLs which are limited, and all of that's coming. I think it would have, I would have preferred it to come around the same time as Tezos itself, but I would say that would be one disappointment.
Is it because of the launching of the mainnet? Do you have that kind of wish, before or after it happened? The mainnet? Is it because of that?
No, I mean I don't think it's like to have to be a specific point. I mean, I guess if we had this type of tools a year earlier, it would be better, of course, than a year later. But it's not. There's no like specific landmark where like no, at this point we need to have the developer tools. It's like I wish they had been a little earlier, but they're coming. Overall, I really like the project. It's I think for the most part it really delivers on everything that it envisioned to do in the initial papers. All right, you want to have one last question?
So the last question that I had for you is, what do you think about decoupling the vote from baking? Because this is, I've actually on both sides, and it's interesting, but I've seen arguments on both sides. So I think it's starting to come to later.
So decoupling the vote and baking. Okay, so here's the problem with the vote. As you know, Tezos cannot work because of voter apathy, which means you'll never reach more than a few percent, except 80%. Quorum has been met. So it's funny when people bring up voter apathy in Tezos, even though the papers are aware of that, and that's why bakers vote as opposed to just having everyone vote, because the idea is that bakers are going to be more aware of probably what's going on than people who are not necessarily there. So if you rely on baker voting, you are going to have people who are basically paying attention to what's going on in details, and that makes sense. Now, the risks that you take here is that bakers are not necessarily representative. Their incentives might be slightly different than other people in the network. That's very true in proof of work. So in proof of work, sometimes you hear, well, miners are completely incentivized the same way as Bitcoin owners because they own these ASICs and they're going to get paid in Bitcoin in the future, but they already made these capital investments, blah, blah, blah. But there's one like very specific issue where they very, very much differ, which is the block reward. If you had any, right now it's not contentious, but once you get closer to the 21 million limits in Bitcoin, then you may have some contention between the miners and the users. So there's some difference here. There's less so, I would say, in proof of stake because, first of all, the miners hold large bonds, and so I would say in Tezos, the miners and the users of the system and holders kind of look similar. They're a little different. Some of them are paying a little closer attention than the others, but they're similar and they have kind of similar incentives. So that that works somewhat well. I don't think there's like big divergence. There could be, of course, but it's limited. Now, the question is whether or not you want to separate it. So it's saying like, you know what, I trust you to bake, but for voting, I want to give my voting rights to someone else. And if you do that, the problem is that some people, the problem basically is finance. So finance is very, very good at taking bundles of rights and then cutting them into small pieces and then giving them to different people. And I have a bundle of rights and it's like, well, I care about that right, but I don't care about that right, and I don't care about that right. So I'm going to sell the rights I don't care about to people who do care about it. And if you start really, really decoupling governance, it becomes easier for people to say, hey, just sell me your governance rights, And it doesn't matter because I'm not going to bake, so you're not getting any reward from me. We don't have any relationship. You're just selling it. You're just selling it to me. And also, I don't necessarily have to be staked. I don't necessarily have to have a bond because I'm not a baker. If you're a baker, you have a bunch of delegation to you. Chances are you have a very large bond. So I'm afraid of losing some skin in the game properties if you start separating bakers and governance decision. that's something that can be managed. But overall, I think the better solution would be to let people override their baker's vote if they want to. I think that's a great solution, so that if you're not paying attention and you don't care, your baker's going to go one way. If somehow you care a lot, well, ideally you become a baker, but if you don't want to become a baker, at least you can override your baker's vote. That's already like pretty solid solution. But the best solution is really to move away from voting. Voting is meant to be a bootstrap mechanism. I think there are better ways of doing governance than voting, like implementing future key, for example. That's a very interesting proposal that I'd like to see. Future key doesn't mean replacing voting, it means doing it in addition to voting. But if you have future key plus voting, the risks that you could have with voting becomes much lower. One also comment that I like to make is sometimes people imagine that the on-chain governance, or Tezos, is used to make decisions. It's not used to make decisions, it's used to ratify decisions. And that's why you have very high threshold, like an 80% supermajority. It's not like, oh, you know what, let's make a vote to decide what's going on. No. You do that off-chain. Off-chain, you take your time, you discuss what, as a community, we discuss what's a good idea, what's not a good idea, and once there's a general consensus on what makes sense, you ratify on a blockchain. And having this very high threshold, it basically protects you against a bunch of attacks, a bunch of vote buying attacks. I'm not as concerned about it as some people who are looking at on-chain governance might be. If you go out and you bind a bunch of votes, and then somehow over a period of 3 months, you make, what's going on? Over a period of 3 months, somehow you can, you force the passage of a bad proposal. People are going to fork you out. So there's a lot of escape hatch against this type of adversarial behavior. What's really important mostly is you put in high threshold, you put in high delays, and it guarantees that you basically ratify a decision that's already been agreed upon. All right.
On that note,
thank you.
Thank you guys for attending. Thank you, Arthur, for coming, and it's been a pleasure.